softwares are generally built using certain models, okay? And you should be generally be aware of how to use a model to build a software. Okay? Now, one of the first models that was given for developing software is something called the waterfall model. Waterfall model is a model wherein you carry out the system requirement of these whatever you have to do, and then put it into a structure, and so that you can revisit what you have done. In waterfall model, you first understand the system requirements, then the software requirements. Now, the main part about waterfall model is once you've gone to the next step, you can go to the one step back. Okay. Once you have moved to the next step, it does not allow you to go to the first step again. Okay. That you can only go one step back. You cannot go two steps back. That is the limitation of waterfall model. Okay. So that means it's a slightly rigid requirement. That means in this kind of a software development, once you have finished this software development, there is no way you can revisit and change any requirement. Okay, so you become very bounded. Okay, that is the main concern of waterfall model. The feedback loop is only one back. So to improve upon waterfall model, spiral model was introduced. In spiral model, you had certain development points. Once you started building the software, you had started certain points. Okay, and you revisit those points over and over a period of development. You revisit it till such time you reach the actually model software which you require. Okay, so this is basically waterfall model put into a loop. Then came the manifesto of agile software development, which over a period of time has become the major software development philosophy. Now, what agile says is software is something which everybody requires quickly. Okay, why? Because there's a need for software to be used in the system to enhance efficiency. So the agile software development philosophy says that you need to deliver, software developers need to deliver working software, okay, quickly. And let's not make it too cumbersome a process so that by the time we build a software and give it, the technology has completely changed. Okay. Now, this was actually a problem area 10, 15 years back, wherein the software development will develop a product project and give it to you, come and field it to you, and then it is not what you wanted. Okay. And that's why agile software development philosophy says, keep giving working software to the client. Okay. And that's why you need to collaborate a lot with the customer requirement so that you keep incorporating changes in the software as and when required, as and when comprehensible. Okay. It does not rely on very, very comprehensive documentation. It relies on responding to any kind of a change which the customer asks for. So there's a beautiful document of manifesto of Agile where there are Agile manifesto given. Generally, developers follow that manifesto. Okay. Now, you were asking, sir, Manish, that how do you find out, how do I trust the software from where I'm buying, right? So Software Engineering Institute gave a capability maturity model, software capability maturity model, wherein you can judge the capability of an organization in developing software, right? Now, once a company starts making software, it is in an initial state of making software. It's in a disorganized state. Okay, that organization would be called as initial. Then second is the repeatable stage. Once you start making software over a period of time, you start now having basic lifecycle management concepts wherein you can do code reuse, you can produce software in a more organized manner. Okay. Then third type of organizations will be called defined organizations, where they have very, very well documented and defined procedures for software development. Okay. You go to that company, they have a process involved in developing software. Then you have managed systems. Managed systems are very, very quantitative measures are there for understanding the development process. Companies like Infosys, in fact, Infosys would be an optimized environment, not a managed environment. Okay? But mid-level segment software development companies would be managed. And optimizing companies are which we are continuously improving, right? You look at Accenture, Infosys, the moment AI comes in, they incorporate AI in their software building methodologies. So they are very, very, so this is how you can find out what is the capability of an organization to develop software. Now, one of the assurance maturity model is called the Software Assurance Maturity Model, SAMM. It's an open source project. Okay, it is maintained by OVAPs. SAM tells you how a business which makes software, what are its development process, and how you can grade a organization as far as its software development maturity has to be assessed. There are 5 functions wherein you understand their governance, design process, implementation, how do they verify softwares, and how they operate the software. Okay? These are the 5 parameters, 5, 6 parameters on which they decide. And there are many things wherein you have metrics defined for each process for software assurance maturity. You just need to know, if you want to assess, you can follow SAM or you can follow capability maturity methods. That's all. Okay. For CISSP, that's all. But they say tomorrow you become a CISO and you want to assess an organization in it, then you'll have to deep dive into either capability maturity matrix or software assurance maturity model. You at least now know that, okay, I can ask for a SAMM based assurance of an organization or capability maturity model of an organization. Right. Oh, this question I will not. In fact, I am also not aware of this question. I think it's logging and monitoring for all 3. I don't know. I'm not aware of this answer actually. Penetration testing, access control, logging and monitoring. You have to see here. Yeah. Okay, this was some high-level question I copied from somewhere, probably. I think it is all 3. Logging, access control, penetration testing, all 3. Okay, let's go ahead. Okay, these are the 12 core security. Okay, I had the answer. The 12 core security practices include access control, security requirements, security architecture, code review, security testing, and more. So it is exactly not given. Okay, just to be aware of that, SAM is one of the ways in which you can find the maturity of a software development partner. Okay, then there is a model called ideal model. Okay, ideal model of software development is basically a company follows the ideal model wherein they encourage continuous learning and improvement. These are the 3 tenets. There's a structured approach to software development. Changes are based on sound business reasons, and continuous learning and improvement is there in their software development process. That is the ideal model. Okay. So if you broadly see this diagram in the exam somewhere, you can understand this is the ideal model. Okay. Okay. Then software developers use Gantt charts. Gantt charts are basically a project management tool to see what is the progress of your project. So generally, a Gantt chart looks like this. Okay, we all know that Gantt chart is basically to track our tasks. Okay, software developers use Gantt chart very frequently to see that which work is in which phase. Okay, very favorite question in CISSP. Then there is something called a PERT chart, Program Evaluation Review Technique chart. Okay. Right. So in PERT chart, what happens is you have milestones. Okay, you have milestones from. It's like a routing table. Okay, you have a software which has to be built, and you have milestones, and all milestones need to converge, and then only the software is supposed to be built. Okay, 1 day, this will take 2 days, 3 days, 4 days. This will take 1 day, 4 days, 7 days. So you come to know that what is the total build time that will be taken by a particular software by the developers. That's called a PERT chart. Okay. Very favorite question in CISSP, Gantt and PERT chart. One question you can expect out of this. Okay. One question and then let's move forward. Yeah, at times, obvious answers are the answers. Okay. So it is B. Right. Okay. Then next factor that we look into, in software is basically change management. What happens in software? There are many times where software will be asked for certain changes to be done. Okay, those changes have to be managed. Now, there are three stages in change management as far as software development is concerned. First is something called a request control. Request control means that somebody has, users have requested a modification, that this is what is required. The customer said. So now somebody needs to control that request and make the managers understand that these are the changes that needs to be done. What are the costs? What are the benefits involved for developing that change? Okay. Then you have something called a change control. Change control is, developers now create user situations to see that whatever the users have asked, can they be incorporated as far as the users have done it. Okay. And then is the release control, wherein you are releasing the approved changes into the production system. Okay. You develop it, test it, and release it into the production system. So what happens in request control? You analyze. What happens in change control? You see that the changes which are been requested can be incorporated, and in the release control, you make sure that the changes which were requested have been tested and developed and meet the required criteria and released into the production. Okay. Similarly, software also undergo configuration management, and it's called SCM, software configuration management. A lot of software you have to tweak to your conditions. Okay. And those configurations are very important to maintain security baselining of your software. Okay. Whenever you have these kind of configurations, you need to audit these configurations. You need to account for these configuration requirements. Okay. So wherein you manage the configuration requirement of the software, that process is called a software configuration management, wherein you look after what are the configuration controls which are requirement in the software, who is responsible, accounting, and are those configurations being audited from time to time or as required by the system. Okay. DevOps is a philosophy of developing software, wherein, what happens is, once you look at Agile, you want to give working software quickly. So how can you give working software quickly? When developers and operations guys are working in tandem, they're working as one team. Okay. So DevOps philosophy is basically what happens once you make software. Okay, somebody writes the code, and this code now has to be put into some physical machine, right, to run it. So basically, this is dev and this is ops. What happens? What used to happen was you write a code and then you give it, and when the operators start operating that software, they get jinxed. Why? Because probably the software doesn't match the hardware, or hardware has to be tweaked. So there's a lot of issues. So what happens? The philosophy of DevOps was brought in, wherein the dev guys, they develop, and the ops guys, they operate the hardware, but there is constant, workflow between the developer and ops guys. And in between came the security guys to put their security control requirements. And this came to known as a philosophy of DevSecOps. And now you tell it differently. You create SecDevOps. Even before you are developing, you lay out the security requirements so that the security is embedded way from the start, even before development goes in. That's the philosophy of SecDevOps. Okay. What is an API? API is something called an application programming interface. Now, what happens is you read, if you look at software development methodologies, there are a lot of pieces of software which is written, okay, and each of the software has to interact with each other. Now, one way is to make them joint code. What happens? The code loses its flexibility. Instead, you write small pieces of code and you make it available through something called a API. Okay. So once you make it available through an API, if you write a software and you need to rely on this input from some other software, you interact with its API. You also have an API gateway. Okay, you interact with this API, you get the required information, and then you program it. So APIs has made cross transactional systems very, very simple. If you look at UIDAI, if you want to do if you want to do Paytm. Look at Paytm. How does Paytm work? Or all the wallets, the PhonePe works. At the back end is the NPCI infrastructure, okay, which is the digital transaction infrastructure. And NPCI has an API through which all these payment wallets, gateway wallets, GPay, ShePay, everyone is interacting with these APIs. Okay. But the back end is the NPCI. Okay. Even UPI rides on this particular NPCI gateway. And APIs make it possible. Okay. Now, API becomes a attack surface. This becomes a attack surface. Why? Because this is public in nature. This is a public API. Since it's public facing on the internet, attackers will do a DDoS attack. Attackers will do input validation, input injection attack. Attackers will do SQL injection. Attackers will do session hijacking. Okay. All kinds of attack which can be done on a website can be launched on an API gateway because APIs are public facing. Public APIs are public facing. There could be private APIs which are not public facing. That's why the way you protect a website is the same way you protect a API gateway. Okay, remember that. And that's why you use web application firewalls to protect an API. It will have same methodologies because it will. What an API does is an API, receives the requests, processes the request, and then gives output in either JSON or YAML, whatever language. So when it's taking an input, it needs to validate this input. If you're not validating this input, then again, you will have an injection attack. Okay. And that's why it needs to authorize, authenticate. How does API give authentication and identification? When you interact with an API, initially at the backend, they issue you a key. This key you embed in your request. Okay. You embed this key in your request. Or you basically, you don't embed the key, you embed the you encrypt using this key. You encrypt using this key. So this request, when it goes with an encrypted with a key which was issued by them, when you receive it, they have your private, they have your public key, and with the public key they decrypt it because API provider provides you the public key, private key here. And once you decrypt it, it knows that the request has come to you. So generally, API keys are your source of your protection. Now, if your API keys are hard coded in your program, you might lose your key. And that's why you should never hard code your API keys inside a program. They are stored in some TPM or some function somewhere else from where you just carry out encryption and send it. Okay. All this work is done at the backend through some software libraries. Only thing you need to require, API keys should not be embedded. Should not be hard coded. Okay, organizations, they at times put their live keys in their code and put it in the public GitHub repositories. Okay. Right. Remember these API points, very important for understanding and securing APIs. All of the work, right? Right. Now, once you make a software, right, you have to test the software. Now, you have to give it to testers to test the software. And software is tested in the same way as you do penetration. Software testing can be done white box testing, wherein you make the complete source code available to the testers. Gray box testing, wherein you make part things available and part things not available. Okay, that's called gray box testing. And black box testing is you give them a user level understanding that this is software, this is how the user will interact. You find out what are the problems with the software. Such testing is called a black box software. Okay. I already told you about code repositories. Code repositories is a good practice for storing and managing code. It is used for, it can give you public access or private access. Public access are public libraries, private access are private libraries. It gives you capability to commit your code, means you can keep pushing your code and it keeps versioning your code. You do not have to manually write down this is today's date code, tomorrow's date code. Earlier, developers used to keep folders of each version. You do not have to do that. The moment you commit the code to the repository automatically versions it as per the day's coding requirement. And that helps you. Code repositories help you in reusing code in other projects. It becomes very, very easy. Okay. For maintenance and management of the code, you need to have a proper SLA to your vendors. Okay, how do you, if you bought your software or you built your software, you need to have proper SLAs with your, software provider. At times, software providers will make you a software, and then they will go bankrupt or they will close down. Then what do? In such cases, you use something called a software escrow. Okay, wherein once your software has been built, you give the software to an escrow. Your escrow maintains your software, and as and when in the time of dire straits you need that software back, they provide you with software. There are a lot of software escrow agencies. There are companies which still provide Windows 7 support. Okay, though Windows 7 has outlived. There are systems which are running on COBOL, which no more exists. There are companies which support such languages also. Okay. A lot of people face problem in this particular domain also, because generally you have not been exposed to software development ever. But this is very generic, okay? Very, very generic. Not even BTech level. It's probably to the 10th class, 12th class level of software development issues. Even I guess 11th and 12th, you write better code than what we used to write during our BTech days.